Give me a second, guys. Out here. Let's see. Give me a second, guys. Okay. I'm going to turn that down just a little bit. I want some chill vibes in here. I guess I'll turn that off. I think it's a little bit too loud. Okay, let me just do one last thing, chat. I don't have like an intro screen yet, so I have to like literally go in here, and you guys are gonna see me live in real time change my thumbnail. Let's change that. Let's put the thumbnail in, and let's go to downloads, and it's this guy. Cool, good deal, and we will save. Alrighty, well listen guys, thank you so much for tuning in. I do apologize for last night. I did a live stream, but I was probably live for like maybe 30 minutes to an hour, which wasn't a big deal, but it was mostly the issue of like me having to abruptly leave. So that's not going to be the case. That's not going to be the case for today. I'm probably going to go for like an hour, hour and a half regarding sort of this weather briefing. Let me make sure that my comments are on here. By the way, if you guys do have questions, be sure to post those down in the comments below. And as you can tell, this is a very impromptu live stream. So keep that in mind. I'm just kind of still in the process of working through live streams and navigating those. So just give me just a second here while I get all of my ducks in a row. And I'll be sure to probably edit this out. We'll see. Or not. I might just leave it on here. Why does it not show? It's so weird, guys, because like when I go to view the live stream on my end, it's really like hard to even find it on my channel. And like I'm logged into my channel, which is really weird. I don't know why that is. I'm not sure why that is. And actually, I am going to turn back on my chill hop. I like that a lot. Let me turn that back on here. Just a second. We're just getting some ducks in a row before we get started. And so today we're going to be going over the outbreak for today, potential outbreak for today. We'll dive into that here throughout today's live stream. But I'll also be taking your questions as well. So be sure to post those down in the comments below. And like I said, give me a moment here. I'm just looking for my stream. Hopefully you guys are having a great Sunday. It is hot as hell here in Illinois. It really is. It really is. Just a second, folks. If you have any questions, like I said, post those down in the comments. I'll be sure to get to those as soon as possible. There we go. I was looking for this damn live stream. All right. That is so loud. All right, hold on. I gotta fix that. That is so loud. Yeah, we gotta fix that real quick, guys. Hold on, chat. Hold on, chat. Yeah, that's so stinking loud. Let's go to sound settings. Yeah, that is so loud. I don't know why that is, guys. So I will just have to... Yeah, if I have to turn it down, let me know. We'll kind of work with it and go from there. So hopefully you guys are having a great day. Happy Sunday. What else did I want to do? Okay, let's minimize that. If it gets to be too loud, guys, and the music is like hella annoying, I can turn that down. I'm just letting you know here. Hold on a second. No, that's too loud. I'm turning it down. I lied. That is like, I gotta figure out why it's doing that. That is way too stinking loud. Where'd it go? Alright, let's turn that off. There we go. I was trying something new. I wanted to get some chill hop in there. I'll have to make some adjustments as we go. Because clearly, for some reason, I don't know why it's like just blasting on the stream. It's like really stinking loud. Let me just get all of my ducks in a row here. You can tell this was somewhat impromptu. Let's see here. Let's get that up. And radar scope. That's up. That's good. All right. Okay. So I think we're good. What I got to do is, at some point, I have to get like one of those intro screens and then probably have it premiere at some point rather than having to do all the setup in the beginning, just to make it a little bit more clean. So that's, we're sort of dealing with a learning curve as far as the live streams are concerned. But we're working on it. So the idea behind this channel is that I'm going to continue to work to improve it. So, you know, I don't want to keep doing the same thing. For example, if you guys notice on my last video, one of the things that I did was I added more edits to it. I did some transitions. I also shortened it by like half. I used to do my videos just like 30 to 40 minutes of me just, you know, yapping about weather. Instead, I decided to cut that down a little bit and make it a little bit more organized, add some transitions, add an outro. I'm starting to dabble with that. And as I go, I want to continue to improve on the video quality. For example, one of the things that I'm going to be working on both today and tomorrow is a video for the Tuesday event. And we're going to talk about all of that today during this live stream. But we do have an enhanced risk of severe weather for Tuesday that's going to encompass Des Moines, Iowa, all the way back towards western Illinois, northern Missouri, and then even as far west as Kansas City. So that recorded video is going to be mostly talking about that particular event. For the live stream today, what I really want to focus on is the moderate risk for this afternoon and evening, and that's going to be for Kansas. Now, tornado threat, we have 5% tor probs for central Kansas. The wind threat's going to be 45 sig for that same area, and that's especially true for places like Garden City and Lawrence. You guys could be seeing that 45 significant probability. Actually, you are seeing that 45 sig probability for damaging winds. And then for hail, 30% sig. And let's not forget to, honorable mention goes to Eastern Florida. They have a slight risk as well. So today's live stream is really going to be talking about the severe weather threat for this afternoon and evening across the Central Plains. The recorded video that I do is going to be for Tuesday, and that's going to be talking about that severe threat that, as we just mentioned, going to be mostly dealing with the lower Great Lakes. We also do have I believe it was a day 4. Yeah, day 4 for Wednesday. And that's going to be for that same system that moves through the lower Great Lakes, eventually impacting the Ohio River Valley. It seems like we're in this broken record where, you know, we have a severe weather threat in the Plains, and then the Midwest, and then the Ohio Valley. Plains, Midwest, Ohio Valley. It's been like that periodically the last couple of weeks, and we're just going to get more of the same here for you folks in Iowa, Indiana, and the mid-Mississippi River Valley. So, as I mentioned, we're going to be talking today about mostly Sunday. I'll probably touch on Monday for you folks that are interested in that. But I really want to dissect today because today could be significant. And we'll talk about why that is. And then, as I just mentioned, the discussion for Tuesday, I'm going to hold off on that for a recorded video. I don't know if I'm going to go live yet for Tuesday. I might. It just depends on what my schedule is. As you guys know, I am going to be moving here to South Carolina on I think, was it Thursday? I don't even know what day I'm moving. Thursday. I have to be out of here by Thursday. And I got to get down to South Carolina by Saturday. So it's going to be really kind of finicky here as far as live streams the next couple of days. If I am able to, I will go live for the Tuesday severe weather setup. Because I am from the Midwest, I think as somebody from Illinois, that'd be very sacrilegious of me not to go live and talk about that for you folks. But I am planning on maybe going live Tuesday. And then, of course, as you see right now, we are live for today. I am not going to be live later on today, however. So this live stream is just a weather discussion for the setup leading up to today, but I'm not going to be live for when these storms are actually ongoing. So if you guys are in tuned to live streams or are looking for ones that, you know, would be really good at covering these, I mean, I could give you a few. I know Evan Freiberger, who I've spoken to on many occasions. He's a wonderful live streamer. I highly recommend him. Max Velocity, Ryan Hall. So I will link those guys down in the comments. I cannot guarantee that they're going to be live, though. I'm just saying that those are sources that I would strongly direct you guys to for coverage on a lot of those storms. And of course, there's others as well, but those are the ones that I've kind of been in tune to, and as somebody that, you know, is a meteorologist, would highly recommend. By the way, one thing I want to note too, there are a few people in the weather community that do live streams that don't have meteorology degrees, but let me tell you, they are phenomenal at it. For example, Evan Freiberger, right? Doesn't have a Met degree, but as somebody that went to school for this, and I've told him this many times, he is a phenomenal live streamer. Because ultimately, it's not about necessarily having a degree. It is about being able to communicate weather in a way for anybody to understand. And when we're starting to talk about major severe weather outbreaks, or we're starting to talk about, you know, a lot of people impacted by severe weather events, that's important. It's really important to have that. So I am probably one of the more unpopular opinions out there, because there's a lot of meteorologists that are really hell-bent on people having degrees in order to communicate weather. I can certainly understand that. But I also, at the same time, will tell you that there are people that don't have degrees that can communicate better at weather with people that do have degrees. So it's kind of a catch-22. It doesn't necessarily need to be a benchmark for whether or not you can communicate weather. And Evan's an example of that. I'm not necessarily singling him out, but he's a primary example of somebody that doesn't have a degree, but yet does a really damn good job at communicating the weather, right? So, and there's others out there that don't, that also do a really good job. And their following proves that, you know, these people have 30, 40, 50,000 subscribers, 100, 200, millions of subscribers even. You know, clearly the proof is in the pudding. So anyway, all diatribes aside, as I always say, let's get into today's discussion. So as we see, we have a moderate risk for severe weather. We just talked about that, but I want to talk about, kind of extrapolate some of the things we have here from the SPC discussion. Now, I am not going to go over everything in this discussion. I'm going to kind of pick and choose what we talk about here. But the one thing to highlight is we have downstream flow field containing several embedded shortwaves, including a convectively generated perturbation now over parts of Kansas and Nebraska. And then the feature should eject northeastward over the upper Mississippi Valley this evening and away from the main threat area. Upstream shortwave trough apparent in moisture channel imagery over the Four Corner region will move northeastward, influence convective potential, yada, yada, yada. Let's go down to the Central Plains, though. That's really going to be the big area. I am going to not really talk about Florida. If for those of you that are from Florida that join the live stream and you want me to cover it, or if you have any questions about it, I'm happy to talk about it, but I'm going to mostly focus on the plains setup for today. So, we have thunderstorms expected to develop during the mid to late afternoon behind the dry line over the eastern Raton Mesa region, as well as along the dry line itself, and move east-northeastward to eastward into increasing moisture instability. And as they do, some of this activity should aggregate into clusters as smaller scale outflows combine and enlarge. If I'm looking for a straight line wind event, guys, I've been preaching this on multiple videos because we've seen some of this happen the last few days. But if I'm looking for the evolution of a derecho, possible derecho, I want to see wording like this when we're starting to talk about smaller scale outflows that combine and enlarge. What that essentially means in the wording itself, you get a couple of these cold pools to set up, and as they sort of interact with each other, you get a larger cold pool. You sort of have this summation take place. And as they converge and as they interact, then you get a larger cold pool to take place. So imagine if I draw these arbitrary cold pools here. And let's pretend these black arcs are cold pools. Well, these storms are going to deviate in different directions, and they're going to cluster in this scenario. Let's say this one moves off and deviates to the northeast. This cell moves off towards the east, and the cell at the very top moves off to the south and east. Eventually, at this particular point, as we draw right here, we're going to see all these cold pools merge. And as they do, you're going to go from sort of cold pool A, B, and C, and you're going to have essentially a big cold pool, and that's going to be cold pool A, B, C, right? So I'm getting a little bit geeky with that. I mean, the simplest way to put it is you got a bunch of cold pools that merge and create a bigger one, and that's typically how we get some of our stronger, large-scale storms. We're talking about MCSs, derechos, and things of that nature, and even sometimes Boeing segments within a larger quasi-linear convective system, also known as a QLCS. All right, let's continue and move through. So, with supportive internal feedback of an organized cold pool, associated forced ascent at the front and rear inflow jet. Remember, rear inflow jet in terms of a supercell. If this was my arbitrary supercell, rear inflow jet is going to be the warm air and moisture advection feeding into the mesolow. And supportive mid-level winds for downward momentum transfer, as well as the residual and diurnally destabilized outflow boundary. The overall meso-alpha scale, I'll talk about that in a second, I'll translate that, what that means, appears quite suitable for an organized, potentially significant severe convective wind swath to result. The most probable corridor for such growth still appears to be across Kansas in and near the moderate risk corridor, driven by wind probabilities. So, immediately as I'm reading this, now we haven't even dissected anything from this discussion. Yo, what's up, Justin? Welcome to the stream, man. Thank you so much for tuning in. We are giving yesterday's live stream another try. So, thank you so much for tuning in, Justin. And by the way, Justin was here during yesterday's live stream. I had to abruptly end it because I thought, like, my dad fell, and I was like, oh, shit. I'm like, all right, this is not important anymore. Let me go downstairs and check on him. And at that point, I had such a long day. I'm like, you know what? I'm not even going to go back live because, you know, there wasn't really much to talk about. So, decided to redo the live stream today. So, Justin, welcome back to the stream. Thank you so much for tuning in. We are just going through the moderate risk right now. So, if you have any questions, Justin, post those down in the comments below. I'm happy to go over that. At the moment, we're just going through the discussion here on the SBC website, and then we're going to dissect it. One of the cool things, by the way, that I really like to do, and you're seeing this in real time, is I like to go through these discussions that the SPC provides and then sort of challenge myself and see, can we point that out on a map? Like, can we observe this in real time? Can we see this on our model guidance and test myself? And sometimes I'll do it in the other way as well. Like, I may start by looking at the models and the current OBS and then go to the discussion and see if all my thinking lines up. I try to do a little bit of both. So we're going to start by looking at the discussion now and then going into some of the latest observations from the region and then look at our model guidance. We're basically following the forecast funnel, folks. We're doing that live in real time. So, from this paragraph in summary, I mean, if I'm looking for kind of a derecho-like event, or if I'm looking for a severe weather threat that is mainly revolving around strong, destructive straight-line winds, I'm looking for terms like cold pooling and, you know, essentially cold pooling, and, you know, just general kinematic thermodynamic support. I'm looking for both. This paragraph mostly talks about the cold pooling aspect. Let's see if we dive into other sort of ingredients too on top of that. Initially, separate dryline development over the northeastern Texas Panhandle, northwestern Oklahoma may blend into or even get undercut by outflow from the broader event as well. After a few hours discrete time to its south, with the threat of large hail, locally severe gusts, and perhaps a tornado or two. Other afternoon development along the dry line in the mountains of northern Colorado and southeastern Wyoming and over the Black Hills may move east-northeastward across a narrow moist sector, produce severe gusts. We're going to skip that part. That's pretty much reiterating much of what was said above. Here's the next portion, though. Near and behind the Kansas to Panhandle dryline segment, storm initiation environment will be characterized by increasing large-scale ascent. So we're talking about large-scale ascent. That means a lot of buoyancy. And large-scale ascent meaning that that air parcel is likely going to fly like a mofo. It's going to our equilibrium level, our EL, our cloud tops, are probably going to be really high from that deep convection today. And upper divergence ahead of the ejecting four-corner shortwave trough. I want to go over that real quickly. When we talk about upper-level divergence, what we mean by that is in the synoptic scale. We're going to talk about that. We'll be sure to point this out. But we mean that in a synoptically driven environment, when you have, and I'll move this over to the side, upper-level divergence, so here is my upper to mid-level winds diverging aloft, I am thereby promoting surface-level convergence. And so that air, when it's converging at the surface, is going to want to rise. That's exactly what it's talking about. Large-scale ascent, key word. Upper-level divergence, synoptically driven. Definitely some key wording there. Any insight on Thursday on the East Coast? SPC hasn't put a risk yet for day 5 yet for the Northeast. GFS yesterday did point to a linear setup. Not sure if it changed this morning. I hate to tell you, Justin. I think that if we're talking about that same system, it is likely going to be linear. Because by that point, I mean, we're talking about the same system here. That boundary is going to move off towards the east, and by the time it gets there, we're probably in the occluding phase. So I would suspect the reason why you don't have a severe outlook yet, number one, because the probs are too low on it. You have way too much disagreement that far out. And then also, considering the fact that this same low pressure system is likely going to be in its kind of later stages of its life cycle, you're likely not going to have a lot of forcing like you did, say, on Tuesday for the Midwest or even for Sunday. So I will be sure, don't let me forget, we can certainly cover that at the end of the live stream if you have any if you want me to dive a little bit deeper into that. But my suspicion is that it's going to be pretty much in the occluding phase if it hasn't been already by that point, and you're not going to have a lot of that lifting. You probably will have some instability out ahead of it, but the problem is it's just going to be sort of at the latter stages. I'll have to check the models for today's event. It looks interesting. Yeah, we're going to go over that right now here in just a few minutes. But what I'd like to do first is kind of go over the obs and what's being observed, and then go into some of the model guidance. Superposition of these effects will lead to nearly 9 degrees Celsius per kilometer lapse rates. That is incredibly steep, you guys. Mixed layer CAPE, 2,000 to 3,000. By the way, if we're looking for wind events too, I want to see mixed layer CAPE really stinking high. 2,000 to 3,000 is more than enough. That is plenty of instability with our mixing to tap into, a lot of potential energy to tap into. That is really, really good. Deep subcloud layer conducive for strong to severe downdrafts will be available for storms over western Kansas from the beginning. Should support growth merger of resultant outflows before activity into greater moisture. Guys, you could play a drinking game with this if you are legally of age. From just this SPC discussion, you could take if you are legally able to drink, take a shot for every time the SPC says outflow. If that doesn't scream significant wind event, I don't know what does. Because anytime they mention outflow, mixed layer CAPE, lapse rates, outflow, I mean, you're just asking for a significant damaging wind situation. Forward prop getting complex in a strengthening nocturnal ML-SYN, at least across eastern Kansas, perhaps in a part of lower Missouri Valley, before it weakens tonight. So we're talking late afternoon and evening for today. And so what I like to do, as I mentioned before, is go over what the latest obs are. And I'm also going to pull up some observed soundings too. Let's do that first. I want to pull up some observed soundings for today. So let's see here. And by the way, I am going to get some chill hop in here at some point. It was just too loud in the live stream. So I'm going to try to get that fixed because I do like the music and the ambiance in the background. All right, so here is the latest soundings out of Dodge. This is Dodge City's observed soundings as of this morning. The one thing to note that I think is really impressive is the fact that this is sort of straight here. We're not like completely veering, but we already do have this backed flow in the upper levels. And you're going to see on some of our model guidance that we get a lot of backed flow aloft. And that's going to be conducive for, more of these deeper convection storms promoting downdrafts. And as I've already said for like the 5th or 6th time, a damaging straight line wind event, essentially. We don't really have much in the way of veering as of this morning. Also to note too, we really don't have a steep inversion. This is a very shallow inversion. You see that here? Notice how your temperature is slightly increasing with height, but it's pretty much scraping the ground. We don't have like a really steep inversion here this morning. So there really isn't much to mix out. The only thing that I'll mention is that you do have this not really saturated boundary layer. Actually, it kind of is. But what's going to end up happening is your temperatures at the surface are going to be increasing, and your dew point is not... I don't know if it's going to increase as much. I think our temps and our dew point, we're going to have a really elevated mix layer, also known as an EML. And you can already see that even right now. Look at where your mix layer, your LCL is. It's about 1.5 kilometers off the ground. So it's very elevated. But I think it's going to be even more elevated by later on today. We'll see if I'm right. Also at the moment too, not much in the way of instability, which makes sense because if you look, we don't really have that much thermal advection right now. It's only, this was as of 7 a.m. Maybe by 10 or 11, we should see some of that increase for sure. Mix layer CAPE is also not where it needs to be at. We're expecting this, as the SPC said, to be anywhere between 2 to 3,000 joules per kilogram. That's going to be very unstable. A lot to work with there in the mix layer. That's going to be really important to talk about. But for the most part, DCAPE, let's see what that's at. 932 already. That's quite impressive. PWatts are going to be relatively low. I think they're going to get to about 1.3 today. But also the other concern too, guys, look at your lapse rates. Now, surface to 3 is not great because we haven't warmed up our boundary layer yet, but we're going to, and those lapse rates are going to jump. But in the 3 to 6 levels, so 3 to 6 kilometers in our mid levels, we're already talking about 8 degrees Celsius per kilometer. That is also going to increase throughout the day. 850 to 500, 700 to 500, we're already in the 7s Celsius per kilometer. And all of those values that you see here in terms of our lapse rates are also going to increase. The other thing that you don't see yet is these sort of upper level shear vectors. Remember, a hodograph is shear vectors. These are going to also increase with time, especially as we get that mass ejection later on today from the Rockies. So you can tell already that this environment does have the potential, and it's starting to kind of warm up and get the juices flowing, but we're not there yet. It's going to be a while before we get some destabilization to take place. But you can certainly see some of the signs very subtly beginning to show up. The last thing that I want to mention here on this observation is that we do have SRH values already between 2 to 400 here from surface to 1 and 3. Remember, with storm relative helicity, helicity is referring to the corkscrew updraft motion of an updraft, essentially, that corkscrew updraft motion with height, right? So if we are able to take what is streamwise vorticity, so imagine a football, right? And we're able to tilt that up, then it looks something like that, right? And that's how we get tornadoes, because you get a rotating updraft, and then you get a downdraft, updraft, downdraft, that produces your supercell environment and essentially tornado environment. So the fact that our helicity is already really high is a pretty solid sign that this environment is just priming the pump at this point. Let's look at one more really quickly here out of Kansas City. More of the same, a little bit more of a messier hodo, and a little bit more instability as well. But you can kind of see the same themes showing up here as far as the lapse rates are concerned. I mean, look at that. You're talking about 7s right now. Very good environment as of this morning. So we'll have to keep a very, very close eye on that. Okay, so let's now head back to the College of DuPage and look at the visible satellite here. Again, if you have any questions, post those in the comments below. Justin, you had mentioned the Northeast. I will, don't let me forget, I will go into the Northeast and we'll check the models on that as well. I believe that my suspicions are correct from what I said before as far as what happens with that. So, just check NAN3K really shows the Boeing of these storms. 45 sig def warranted. Those lapse rates on the observed soundings are quite concerning. All right, well, let's take a look at that. I mean, not really much to write home about with the visible sat here. I was just seeing if there was any southerly flow or any, HCLs showing up here. Let me look real quickly. And yeah, we just have a bunch of cloud cover at the moment. I don't know if these are gravity waves. These might be gravity waves. I'm not 100% on that. But we do have just some pretty stratiform Q fields showing up, and we do have some actually shower thunderstorm activity firing off here in northwestern Kansas. But this is starting to clear up off towards the south. I'm not too particularly concerned about a lot of this cloud cover right now, but it is something to keep an eye on here over the next couple of hours. All right, let's take a look at that NAM3K that you were talking about. One thing to note, Justin, with the NAM3K, and for those watching, is that it is it has a linear bias. Let me go through the model first and show you. So as of 20Z, this takes us into 20Z. This is the latest NAM3K. It's actually rendering right now. We do see shower and thunderstorm activity initially firing off in what would be northwestern Kansas. And then that grows upscale, forms a huge Boeing line, and that races east. What I mean by what I just said, Justin, is so the NAM typically has a linear bias. Why I'm not taking that into account this time is because we're already trying to forecast for a large-scale severe weather event as opposed to one that's more supercell and cluster-driven. So I would actually concur with what the NAM Nest is showing. Let's see, though, if the HRRR is doing some of the same. Well, it looks as though the difference lies in the placement of these storms. So, for example, if we go back to the NAM Nest, we have initial development up towards northern Kansas, and then that dives off to the south as we get a bunch of cold pool mergers with some discrete to semi-discrete activity off towards the southwestern portion of Kansas. But as we go forward and we look at the HRRR, on the other hand, we have initiation starting out in southwestern Kansas. Now, I think the HRRR is picking up on that because we have a crap ton of cloud cover up in northern Kansas, which could cause some insulation concerns. But in southwestern Kansas, we have a lot more clearing taking place, as we just saw in the visible sat. And I think that's what the HRRR is picking up on. So that's my guess. But both of which are showing clustering taking place. We're not seeing supercells here, guys. We're not seeing discrete to semi-discrete supercells. This is all just linear clustered mess. And then the HRRR even picks up on some form of what could be an MCV that initiates out towards northern Missouri and south central Iowa. That could be interesting because MCVs can be pesky. They can actually produce tornadoes in an environment that you might not be thinking would produce tornadoes. They can be really pesky. I forgot to mention, from the SPC discussion we just did, they talked about the idea of meso-alpha scale. Okay? I'm not going to get into like what that means, but to put it simply, they're just being a little bit more overly sophisticated. Sometimes they will mention like actually breaking down the mesoscale. So the mesoscale is not just one scale. Technically, it was actually Ted Fujita that started it. The mesoscale actually has three. I think it's alpha. I think it goes down to beta and then gamma, or A, B, and C. I don't remember, but I know it splits off into multiple different scales, and that's what they're referring to. They're saying, well, within the mesoscale, call this your arbitrary mesoscale, mesoscale alpha. It's going to be at this scale as opposed to, say, beta. That's all it's saying. But otherwise, I mean, mesoscale is mesoscale, right? Let's just kind of, I'm going to refer to it as that. I'm not going to like go over the alpha, beta, gamma scale. You know, I'm not going to do that for you guys. So yeah, I mean, right now at the moment, there is a lot of confidence from our convective allowing models that we are going to see this sort of linear event or MCS event, I should say. So let's head to the href. No, actually, I lied. I'm going to go to pivotal. I don't really like the href as much. And let's go to I'll look at the RFS 6Z. I'm going to say, though, I think the RFS might be a little bit too crazy with this one, guys, because it's showing a crap ton of supercells. So I wouldn't be too bullish on it, but let's zoom in a little bit here on Kansas. And so, yeah, the NAM12 is showing the southern storms forming in Kansas, but it wants a few hours to develop the northern side, then it merges. Yeah, that's kind of what we just saw for the most part. I don't, it's going to ultimately depend on how much cloud cover just keeps blowing off the Rockies for northern Kansas, because what we just saw is southern Kansas pretty much open for season right now. So it may actually end up starting there. if this cloud cover continues. We might actually see initiation out towards southwestern Kansas as opposed to northern Kansas. That's my guess. Because the HRRR, remember, I mean, Justin, these convective allowing models, they're going to be feeding off of just raw data as it comes in. And because the HRRR refreshes every hour, it's picking up on that and saying, hey, wait a minute, there's a lot of cloud cover. I don't think we're going to get initiation here. And we also have storms kind of moving through too. However, well, I'll save that next part for a later discussion. But I was going to go into how actually storms moving over the same area, like the rain we're seeing here in northwestern Kansas, can actually cause negative buoyancy at the lower levels and thereby actually help to enhance cold pooling. But I'll save that for another day. It's a little bit more complicated. So this is the RFS, though. We see those showers continuing, and then it has initiation in southern Kansas. And then you get some initiation in the northern portion, and then it moves off to the east. Interestingly enough, I think on previous runs, the rapid refresh was showing soups. Was it? Yeah, it was. Okay, so in the northern portion. So the rapid refresh volumetrically tends to like print supercells because it's derived from the FV3. So that idea, I just want to make clear to folks, I'm really not bullish on that. I'm really not bullish on that for today. I am more bullish on the idea of what we're seeing on most of our cams, which is that, you know, we get initiation to take place, but, you know, eventually we just grow up scale. We get some discrete activity to semi-discrete, but then immediately it's going to want to gust out and then merge. I am a little bit skeptical on even like this cell forming. Now, for folks in northern Missouri, you guys have a supercell firing off later on today as well. This, by the way, would be later on in the afternoon and evening. But Kansas, I'm not too sure about. I don't know. I mean, the environment's there. We just got to get that damn cloud cover out of the way. That insulation is going to be kind of a problem, which would thereby limit the severe weather risk, I think, for mostly, you know, southern Kansas, and then, you know, really limit the tornado potential. Right now, the SPC has a 5% TOR. I think that that's as high as it's going to go. I don't think it's going 10. I'm going to be honest with you guys. I think the main threat today is going to be hail and winds. Steep lapse rates coupled with damaging winds. The initial hail threat is likely going to be in the first few hours of this event by the time we get to this afternoon and evening. But then once we get sort of this larger cold pool to take place by the time we're at, say, 7, 8 o'clock across central Kansas, then we're going to be mostly seeing some damaging winds. Now, if some of the kinematics can be realized, I know we still have some strong shear vectors, but if we get better veering in the low levels, some of these storms within that line embeddedly could rotate. So I want to make that clear. I mean, I think that's why the 5% is there as well. It's not just for the idea that we get supercells with a higher tornado probability in the early onset of this event, but it's also if we get some sort of mini rotations within this line that forms that eventually moves off to the east. That's certainly a potential too. And then that takes us into the overnight hours. That's going to continue to move off to the east. We eventually do get capped, and a lot of those storms are going to weaken. But for folks in northwest Illinois, eastern Iowa, you want to keep your eyes to the skies because these storms are going to be moving off eventually to the north and east, and those could actually reinvigorate and re-intensify by the time we get to Monday morning and afternoon. There is a marginal risk of severe weather for you folks up in that area, even extending as far north as Wisconsin. So that's the latest on the model guidance right now. But what I want to do first is take a look at a couple of these HODOs that are showing up too. Remember, guys, hodographs are really important. They're very important because what they're going to do is tell you what the storm's feeling. And so that's critical. Right away, I have seen these soundings for the last few runs, and I want to go over that. So the first thing that comes to mind for me, and by the way, just for context, I pulled a sounding from what would be central Kansas by 21Z. Okay. Clearly, if I was to follow this Cape plume, you can see where your thermal advection is taking place. It is following that Cape tongue. It is pretty clear as day, you guys. Just check the WPC. Upper Midwest has a 15% for day 3. The SPC Upper Midwest? Yeah. Okay, day 3. Yeah, sounds about right. That's for day 3. I was talking about Monday. So, I think day 2. Day 2, I think there's a marginal. Let's see. I thought there was a marginal. Let me double check. I could have sworn, unless if they upgraded it. What's Monday? Yeah, so this is... So when I'm talking about like those storms in the morning, I'm mostly talking about that marginal. Problem is, there's going to be a lot of capping for you folks like in Quincy and Eastern Iowa. However, Chicago could be kind of interesting. That may actually go slight. We could see an uptrend to that. We'll see. But if you're in Chicago for tomorrow's kind of a wild card, and that could be interesting. I'm not going to lie. Oh, for flooding. See, for a second, I thought you were talking about the SPC and you just did a typo there. 15% for flooding. Well, that makes sense, right? Because you're just going to have a bunch of training of storms over the next 2-3 days. That makes a lot of sense. Okay, thank you. So thank you for that correction. I had assumed that's what you were saying, but I didn't want to, correct you. I just kind of assumed you were... you did a typo there. All right, so let's go back to this real quickly. We're going to pull a couple of soundings for you guys for the event for Kansas. So these, as I was saying, these are the soundings that I have been seeing for the last few runs. And there is quite a bit to talk about on here. And I'll just kind of point out the big takeaways. Excuse me. The first is, look at our cape. That cape is wild, right? So really nice cape all throughout this profile. We're talking about 3,500 surface cape. However, look at our LCLs, you guys. So our LCL, our lifted condensation level, is about 2.5 kilometers off the ground. And if you're wondering why, it's because look at your temperature. We alluded to this on our observed soundings from this morning. The temperature forecasted for central Kansas as of this afternoon and evening, 91 degrees, and your dew point only rises to the low 60s. So you have a really deep mix layer, right? Deep and elevated mix layer aloft. And then you also have, actually I should say this, you have an elevated boundary layer, and then you have a little bit of this loaded gun taking place in the mid-levels. So what that tells me is your lapse rates, even without looking at the lapse rates in the bottom left-hand corner, are going to be steep as all hell. And by all means, let's take a look at it, right? Look at this. Surface to 3, 9.3 Celsius per kilometer. 3 to 6, 8.6, 8.6, 8.8. I think this is probably the steepest lapse rates I've seen this year. These are really freaking steep. Yeah, so if you're wondering why there's a 30 sig hail today, well, there's your answer. You have a really elevated, essentially, mix layer. You then have a stout, essentially, mix layer too in the mid-levels. You have an elevated boundary layer, steep mix layer, and also, to top it all off, you have pretty much backed winds with height. You get essentially some subtle veering, but then you're backed. Notice how, for the most part, we have this sort of elongated hodograph. That's telling us really strong winds with height. So notice how, I know we're not seeing that cyclical veering shape that everybody loves to see, and it is easy on the eyes. This, on the other hand, is not showing really good veering with height. At least in the low levels, we're not seeing that turning in the lower levels. It takes a while for it to veer with height. And how you can tell that too is because look at your hodograph, like the song Nickelback. You can see that it's veering, but it eventually finally veers once it gets to the upper levels. That's not really supportive for supercell development. Mostly just maybe some semi-discrete, but then eventually outflow. And that's because, again, you don't have really strong low-level veering here. It's clear on this hodograph you don't. And also, your storm, your relative wind vector is also not as stout either. And if we were looking for that vector, it's going to be within this sort of perpendicular that's formed here by your storm position, your right mover. Notice how we don't have this big elongated hodo, and it's not stretching all the way out. So our storm relative wind here is not that strong either. So clearly the Tor threat is going to be pretty much within that 5% that we've seen. Have you thought about the Discord server? I saw you weren't in Thunderbite anymore. I don't want to get involved. A drama there if there is. No, so me leaving Thunderbite was a personal choice. So I'm no longer going to be in Thunderbite. That was just a personal choice for me to kind of get away from drama and things like that. However, I will likely be making a Discord at some point. I have a Discord. I can send it to you. And actually, I'll have to remind me to do that at the end of the stream too. I'll post my Discord in chat for you guys to add me. But as far as making like a Discord server, yeah, I certainly have thought about that. And to be honest with you, Justin, I probably won't have that created until I would say probably by the end of. It'll probably be early next week, not this week, but the next week, because I'll be moving down to Carolina. So it'll be a bit. It won't be this week, but certainly next week. And remind me to do that because I definitely want to. I think that's going to be really cool for our viewers and subscribers and things like that. So yeah, hopefully that answers your question on that. The other thing is, let's look at the her on this particular event. Let's see what the Hodos are showing here. Now the Hodos are actually showing it. So you can clearly tell, I mean, there is some veering that it's showing, but notice how it's really subtle. Like you're not getting a crap ton of veering here, but you certainly do have really strong shear with height. Again, you have elongated Hodos that's telling you really strong winds with height on that. So let's take a sounding here from what would be central Kansas-ish. And more of the same, guys. Clear agreement on the lapse rates, 9.3, 8.6, 8.7, 8.5. Instability is very high. Lifted index is also very high. And once again, your LCL is like completely off the ground with your surface temperature of 88 and 61. So very, very strong instability there. And also beautifully elongated Hodo. How do we know that? As I mentioned a few times already, these colors are corresponding with your wind barbs with height. And so these are very strong winds that we're talking about. I'll have to go now, heading to Grandma's today. Keep up the good work. Although the journey may start slow, you'll eventually get to your goals. Almost already 50 subscribers. Yeah, Justin, thank you so much. I greatly appreciate your support, my friend. And yeah, I mean, like I've told you before, and like I've told people here, I am all about just providing content for you guys and talking about the weather. So I'm not, you know, I love to grow the channel. I want to keep growing the channel, but I also want to continue to improve the quality as well. And make this an enjoyable experience for all of you guys. And be sure to answer all of your questions too. So, Justin, have a good one, man. Take care, my friend, and we will see you on the next live stream. Let's go over this sounding. Like I said, actually, we already did. I didn't even realize that. But just to recap, quite a bit of instability. Mixed layer Kate, by the time we get to this afternoon and evening, is around 3,000. And lapse rates here, 9.3, 8.6, 8.7, 8.5. So really stinking steep, incredibly unstable environment. And the other thing we alluded to early on is the EL. This is really elevated and off the ground here. Well, that was our LCL, but our EL is going to be around 12 kilometers. So very deep convection. And just like with our other profile, a lot of potential energy to tap into. So that is pretty much it. Although I wanted to go over one last thing because I didn't go over this with you guys. And it would be so sacrilegious of me as a forecaster to not do this. But what I want to show you is just the synoptic environment. Because if we remember from the SPC discussion, they had talked about the idea that we have this forcing for ascent and upper level divergence. How we're getting that is we have these two jet streams. So we have our polar jet, as indicated here by this pink line, which I'm actually going to draw over in black. And then we have this Pacific jet that's out towards from the southwest. And so that's going to be kicking up quite a bit of jet flow from both ends. And so what's going to happen here is we don't have necessarily like a jet coupling, but if you notice as we go forward here this afternoon, you see this flow that ejects right here in central Kansas as that moves over the Rockies. And so we get forcing for ascent out towards the Rockies. We get this subtle jet coupling and a couple of these little perturbations that fire off. That creates some stronger winds in the upper levels. And by the way, this is our 500 millibar jet. So this is our jet stream. And so we are getting some stronger winds aloft as that mass ejection takes place moving across the Rockies. You can see here, boom, look at that. Right over central Kansas, clear as day on the HRRR. And if we look here at the low level jet, We see southerly flow, but by that point, that low-level jet really doesn't kick in until by the time we get to the overnight. That's why I think that there could be a tornado potential, mostly for what looks to be eastern Kansas, because we get sort of this nocturnal low-level jet to fire off. Notice how our strongest of winds don't really initiate until like later on tonight. So I would actually argue that early on is going to be the hail potential, and then the followed by damaging winds and hail, and then you're going to get an all modes hazard type by the time these storms mature and move over eastern Kansas. I think the HER shows that, and a lot of our cams are showing that too, which makes a lot of sense. So that's why. I mean, we're not seeing the level veering really until later on tonight. So don't put your guard down. Just because we see initially like mostly just damaging winds and hail, that doesn't mean that we're done. It just doesn't. You know, it doesn't mean that we're going to be, you know, not in a tornado threat because the storms don't have the supercell structure. As a matter of fact, we might have a similar case like we've had the last few times there's severe weather in the plains, where the tornado threat isn't realized until the evening and overnight hours. That's probably going to be the case because we get this nocturnal low-level jet to form as shown here by the latest HER, or one of the latest runs. Let's go to the 12Z and see if it's still showing that. Let's see here. So if we go to 2, 5, yeah, same thing. Same thing. So we get that low-level jet to form, we get that least cyclogenesis to take place, and so much of our tornado threat will likely be towards the latter half of the event. And then lastly, before I forget, I wanted to show you guys how we're getting these lapse rates, in case you're wondering. So let's go to our 700 to 500 millibar lapses, and you can see, look at how that just ejects eastward, right? And it makes sense because if we remember, we have our polar jet towards the north, we have our Pacific jet towards the south and east, and these are kind of coupling and converging at a point. Now, they're not completely coupled yet, and they won't be until Tuesday. But we get this westerly flow or southwesterly flow to eject off the Rockies and then displace a lot of those steeper lapse rates eastward, as we see here on this map towards the Central Plains. You notice those lapse rates are really stinking high, guys. Really stinking high. So that's going to create quite a bit of instability, as we've seen on a lot of the soundings that we've pulled. And then finally, if we look here at our dew points, and we see sort of a dry line component. By the way, if you want to know where the dry line is, here is the best tip for you guys, for you forecasters out there. Always look for the southwesterly barbs. Look to see what your winds are doing. So for example, if we're looking here at 20Z, so later on this evening, first of all, I want to identify where's my cold front, where's my warm front, where is my dry line, because I definitely have a dry line. Well, my southerly flow, if we follow these sort of surface winds, moves southerly, 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 and then we at some point get easterly, but that's probably all the way back here towards the lower Great Lakes. So the warm front's pretty broad. It's going to be somewhat painted within, I would say, within this corridor somewhat, but it's not as well defined by this point. We just have kind of this broader warm sector and this moist sector that takes place across Missouri and Kansas. Clearly southerly flow, so there's our jet, right? There's our southerly moisture and warm air advection. Southwesterly flow is going to be drier air, and then our cold front is going to be where our winds are backed and out of the west, and so that's where we would expect to see some of that forcing taking place. Now, if you want to know where your convection will initiate, you just got to follow your barbs too. So you have your southerly flow, and then your southwesterly flow, where those meet at a point. That's what we call our confluence zone, meaning our southerly winds are essentially intersecting our southwesterly flow. And so that's exactly what we're happening here. It's exactly what we're seeing here. And so this HER run would show initiation taking place right near southwestern Kansas, because as you see, we have our southerly winds and then our southwesterly winds sort of converging at a point. That's where we expect the early initiation to take place. But if we put this in motion, notice how we see this sloshing back and forth within that line. You see that here? Let me get off that. See that sloshing that takes place? So watch this line here. Sloshes west, sloshes east. You see that constant sloshing? That is the dry line. And then eventually that's advected eastward by Tuesday because our winds become a lot more backed towards the west. So we clearly can see a dry line here on our dew point wind barb surface map. And we can also see, if you actually look very closely, this map actually picking up what would be an MCS complex. Notice that little miniature low pressure system racing across towards the east of that moisture plume. That's indicating an MCS as that moves across southeastern Kansas and into central Missouri by this evening. So that is going to do it for today's severe weather live stream. This was just a discussion for you guys. Whether you're watching this live or you're watching this later on this afternoon, if you have any questions regarding the severe weather threat for today, be sure to post those down in the comments below. Even if you're not here during the live stream right now and you're just watching this for the first time, post those questions down in the comments below, and I'm happy to answer those. And as I was telling my friend Justin here in the chat, I am planning on making a Discord server here by not this week, but the next week. So stay tuned for that. Listen, guys, thank you so much for tuning in. If you did enjoy the live stream, be sure to like and subscribe, share with family and friends. And we are not going to be doing a live stream for the next couple of days. We may do one for Tuesday, but I'm also going to put out a pre-recorded video for you guys talking about the significant severe weather risk for Tuesday as well. Thank you so much for tuning in, and we will see you on the next weather live stream. Take care.